Zach, what'd you get for the Dom? Yeah. Swing your legs around. Troy, what'd you get for the Dom? Very good. Well, I think that's right. I haven't actually done it. Let's see. 2a. So you multiply this one by 2 and you get negative 8i plus 10j. And then you just add that to, subtract vector b. So negative 8 minus 3 is negative 11. 10 minus negative 2 is 12. And you're correct. I should have asked for the magnitude of that, but I won't because the second part of the DOM reviews over both of those things. Let's see. Find the angle between. The angle between two vectors was given by this formula, and if you don't have this, you need to write this down somewhere. No, it's dot product on top. Dot product on top. What?
Oh, yeah.
Yeah, I just changed it. A and B, dot product, and then the product of their magnitudes on the bottom. So first off, their dot product. If it equals 0, what do we immediately know? I'll be impressed if somebody uses the right word here. Orthogonal. What'd you say? Is that what you said too? Oh, no. Orthogonal means they're perpendicular. Alright, dot product. 4 times negative 3 is negative 12. 5 times negative 2 is negative 10. Dot product is negative 22. Fizzling tight. Now for the magnitude. A squared plus b squared equals c squared is going to give us square root of 41 for the first magnitude. A squared plus b squared equals c squared is going to give us square root of 13 for the second magnitude. Just Pythagorean theorem with those two sets of numbers. That's something you better be good at by now. Punch that in the calculator in degree mode. While somebody's doing that, I'm going to boot up my calculator. And somebody tell me what you get. 17.65 degrees. And we can kind of graph these and see if that looks about right. Negative 4i plus 5j is going to be up here. 3i minus 2j. 3i. Ooh, that doesn't look right at all. That sounds more like it should be something big. Did you use cosine or cosine inverse? Yeah, that would do it. Cosine inverse of negative 22 divided by radical 41 times radical 13. 13. Close. Ah! Delete. What? I just put you in degree mode. Why did you not do it? That's what I'm getting as well. I chose this particular DOM because I'm not sure that I put one of these on the review, but I know there's one like this on the final. So I wanted you to see. I'm not going to tell you. You may have just to do the dot product. You may have to find the angle between. You're going to need to know something from this DOM on your file. And of course, if you did the final thingy, then no, just this is the dot product. That was a dot b, gave us negative 22. You just multiply the I values, multiply the j values, and add them together. That's all you got to do for that. Alrighty. Since no one's here today, I'm not going to pass out those huge pack of papers. Okay. Yes. Now, let's make sure that you receive... You did log in, right? Are you serious? Like the whole time earlier when I was like, hey, is everybody logged in? Some excuse. Yeah, me and Austin don't buy it. Are we receiving? We are? Tintin said yes. Give me your bloody clicker. Yes. If you're not, if you ever aren't, hold on, let me just start over real quick. Yeah, you are. If you're ever not, if like nothing ever happens, if you hit that top middle button, sometimes it'll wake it up. But you did receive. Okay, I know we received because people are putting in answers. Take that. Okay. Who has not seen the receive? If you ever want to know, just put it in answer and enter. If your initials pop up there, then you did receive. Oh. Everybody logged in? I didn't go through it. That's because you weren't logged in time. You hear the hostility in my voice? Oh. We're going to practice again since we have like bukus of time and only 9 review problems today. Yo, I changed my mind. It's 10. We're going to do 11 tomorrow. Hey, blah blah. Now look at your clicker. Are you receiving?
Yes, I am.
Yeah. Good. Yes, first freestyle, clear answers. Of course, on test day you'll have multiple versions, but that I'm not going to bother doing that for a review. Here we go. Here we go. A piecewise function is given. Use the properties of limits to find the indicated limit or state the limit does not exist. What is this going to look like? That's right, Rachel. It is going to look like a piecewise function. That was you, right? Oh, I thought so. Very good. Now, we are asked to find the limit as x approaches 4 from the left, negative 4 from the left, negative 4 from the right, and negative 4. I like this problem because the piecewise function is really it's just there to throw you off. Why is the piecewise function completely not relevant to this problem? Come again? Yes. Normally, when we do piecewise with limits, the part we're looking for is the part where they split. Therefore, kind of making these two things work together. This one, these things split at 0. We're looking at negative 4. Let's think about this for a second. This is going to look like this up until a certain point, and then it's going to start just being 4, right? This is what our piecewise is going to look like. Ish. Okay? Normally, we're looking for the limits of these two parts, right? Oh, this is the limit of 4. That's 0. They must not be the same. However, this is interesting because it's asking us about negative 4, which is like way back here. The piecewise portion is completely irrelevant to the limit we're looking for. So make sure you look at that on your test and don't just go, oh, I need to immediately start plugging in 0. If we plug in negative 4, which function are we going to plug it into? The top one, less than 0. Plug it in, what do you get? If you plug negative 4 into that top equation, what do you get? So which one does it have to be? C. And the reason that it's, notice, the left limit, right limit, and the overall limit are all the same because the function's continuous right there. There's not even a break. So it's kind of a trick question. Oh, I forgot to have you guess it for your... Put C into your clicker. The next one I'm going to have you guess before we do it. Shuckles. Okay. Questions on this problem? Find the exact value of the trig function. I don't care if you use a calculator. Although it's probably easier not to, because you know they're going to put it in some kind of radical over something. What's this going to look like? Yeah, it's a trig function, like cotangent of something. Or secant in this case, of something. Easiest way to do this is just to look at your unit circle. What is secant the flip of? Cosine. On your unit circle, what is cosine of 7 pi over 4? Well, I think Jordan's going to win this race. Cosine 7 pi over 4. Yes! Radical 2 over 2. However, we are looking for secant, so what do we need to do with that? Flip it! 2 over radical 2, but when we rationalize that, what's... So that's going to be 2 radical 2 over 2. Cancel, cancel. And the answer is... I forgot to have you guess again. Dang it. It is Bravo. Questions? Any questions? What's this going to look like? Boy, these directions are easy today. Now, I'm going to remember this time. Take a minute. If you think you know how to do it, and put in your answer. And I'll pause the video so the people at home... Okay. Long division. What? Uh-huh. That stinks. Don't forget to put in your missing terms so the things line up. 6x cubed minus 3x is 2x squared. Multiply. Subtract by the whole thing. So 0 minus a negative 2x squared is positive 2x squared. Aha! It is going to be positive. We were right to cross off C. 2x squared divided by 3x is 2/3 x. Of course, you could have told that because the second term in every one of them is 2/3 x. So when in doubt, look at the answers. Multiply that back through, and you get 2x squared minus 2/3 x. 0x is all that comes down, so minus a negative 2/3 x is a positive 2/3 x. What is 2/3 x divided by 3x? 2/9. So far, so good. So multiply that back through, you get 2/3 x again, minus 2/9. Minus 2/9. Multiply 2/9 by, I already did that. Drop down the negative 2. Subtract. Negative 2 plus 2/9. So that's negative 18/9 plus 2/9 is what, 16/9? And it is a negative 16/9. So which one of these is the answer? Hey, I was right. Sure. Those kinds of guessing strategies will be very beneficial to you on a multiple choice math test of any kind. Again, they're not 100%. It could have been C, the first one we marked off. But if you have to guess, you might as well use logic. Because you have to remember, the test takers are trying to lead you to the wrong answer. So if one of them is very different than all the others, most likely that's not the case. Of course, this would have failed us in the last problem, or excuse me, 2 problems ago, because the one that was most unlike the others, it turned out to be the answer. So again, it's not 100%, it's just guessing. Of course, the best way would just be to know how to do it and answer it, but speaking universally. Questions on this problem? All right, what's this going to look like? I think you might be right. Negative 4 row 1 plus row 2. You can do this one row at a time on your calculator, but I think it's just easier to do it. Negative 4 times row 1 is going to be negative 16, 20, negative 4, negative 4. Adding that to row 2 is going to be negative 20, 20, 1, and negative 6. All I did was add these. The other two rows shouldn't change. So therefore, it couldn't have been C or D because the other two rows shouldn't change. Only the second row in a row operation should change. And therefore, the answer is what? Bravo. Questions on that one? Okay. 3a minus 3b. I didn't want to bother covering up the problem on this one because it just says solve the problem. So take a minute, look at that, put in your answer on your clicker, and then we'll look at it. Okay, here we go. Fine, fine. 3a, geez. 3a minus 3b. So let's just do this one term at a time. 3a on the first one is going to give us negative 3 in the first number. 3b on the second one is going to give us negative 18. I haven't done the minus yet. 3a minus 3b, so this minus this will give us positive 15. Therefore, the answer would be, and we only had to do one entry. Questions? The rectangular coordinates of a point are given. Find the polar coordinates. What do you think is... Nope. All it's giving us is the coordinates. What? Yeah, like 2x comma, or maybe just an x comma y. Yep. I guess so. Okay. Here we go. How do you find polar coordinates given rectangular ones? Ooh, hush falls over the crowd. That's absolutely something you could do. Or there's a formula that we used in the review just like 2 or 3 days ago. Or you could use logic. Go. Tell me about your logic. So you can cross off B and D. Maybe. But you can definitely narrow it down to A or C by using that logic. Now the formulas in your book say this. If you're given x and y, you can find r by just doing x squared plus y squared equals r squared. So that'd be 4 radical 2 squared. (16 times 2 is 32. 16 and 2 is 32. That's 64, and therefore my radius is 8. Now, because of Josh's logic, we can then conclude that it's A. However, to find the angle, if you did forget how to graph rectangular coordinates, is they also gave you this formula. Tangent of theta equals y over x. Well, what's y over x going to reduce to in this case? Yeah, it's just 1. They're the same thing. So take inverse tangent of 1, and it should give you the angle. Inverse tangent. But remember, the problem with using... Okay, you would have still need a trig. If your calculator had given you 45, you could have obviously known that that was not correct. But remember, every trig function has a twin quadrant. Okay? 45 is in the first quadrant. What other quadrant is the same as the first quadrant for tangent? The third one. That's right. In case you have no idea what I'm talking about, for instance, sine values. Sine values are going to be the same in the first and second quadrant because they're going to be positive up there. And they're going to be the same in the second and third quadrant. Third and fourth. Cosine are the same on each side of the y-axis. These cosines are the same. These cosines are the same. I think you're thinking coterminal. Oh, okay. And tangents are the same in these two quadrants and these two. So 45, its little counterparts are going to be down here. So things you can remember, or you can just use logic and things like that. Other questions on this problem? But these are the formulas, by the way, that you need to have down for polar coordinate given rectangular. Because you need r theta, and that will give you r and theta. I did unpause this thing. Any questions? Find the distance between a pair of points. What's it going to look like? Yeah, just 2 points, you're going to need distance formula. I'll give you a second to try to solve this and put in your answer. Yes, ma'am. Sure. I would strongly suggest you condense them, because I've seen a lot of people spend most of the time flipping through 800 pages because they bring in all their homework and all their notes, and then they have like this huge novel and they're like searching for stuff. But yeah, you could. Well, if you printed off the thing that I put on there for bonus, then you'll know exactly what you'll need. But I've taken that off now, so because it was only for that weekend. Sorry. So, -7 minus -3 is -4 and 2. What am I doing? This is slope formula. Just kidding. Yeah, my bad. x2 minus x1. y2. Oh, I did the y's first. Just gotta have it. 16 and 4 is 20. Really? You never had to use that on ACT? Slope form or distance formula. Now I did my x's and y's backwards in case you're wondering where the 16 and the 4 came from. But then I got radical 20, which breaks into square root of 4 times square root of 5, which is 2 radical 5, hence D. Sorry about that slope thing. Brain mistake. Questions? What do you think? Yeah, no kidding. What's it going to look like? Or it could be a looking for a movie with Keanu Reeves and Lawrence Fishburne. Seriously, nobody's seen this? Yes. Or it could be a matrix. The determinants of a 3 by 3. Remember, there were two methods. You could do it with the minor method, or you could have done it with the diagonals method, which I'm going to do now. The diagonals method. 2 times 6 times 3. Sure, I'll do both. Plus 4 times 4 times 2. Plus 5 times 2 times 5. Minus, and we go up the other way. 2 times 6 times 5. 5 times 4 times 2. 3 times 2 times 4. So 112 minus 124. Man, I don't think that's even right. It's 118 minus 124, which would be negative 6. Doing it the other method, you could have done the minors, which means you take the first row, putting a negative in front of the second number. Then you take the minors. The minor of the 2 would be 6453. The minor of the 4 would have been 2243. And the minor of the 5 would have been 2625. And then you do the 2 by 2 determinants. 18 minus 20, negative 2. 6 minus 8 is also negative 2. 10 minus 12 is also negative 2. That's kind of weird. So that's negative 4 plus 8 minus 10. Negative 4 minus positive 4 minus 10 is negative 6. And you should have gotten the same thing both ways. All right, last problem. Are there any questions on this one? Yeah, but when you're watching a teacher do something, it always looks easy. The teacher's like, you know. Well, what do you have her for, stats? Yeah. No. Problem is, some people are just so smart, and I think she falls into this category, that it's like, she's like the Sheldon of the math department. It is going to be a graph. Use the graph to find the indicated limits. And I don't mean that in an obnoxious way, because Sheldon's obnoxious. I mean in like a wicked smart way. Okay, find the limit as x approaches 1. What's the limit? Negative 3 is correct. What is the function approaching as it approaches x equals 1? And it is the y value of negative 3, which would have made it a or c or b. So what is the actual function equal at f of 1? Positive 1, therefore making the correct answer a. What? Oh, what? Wait, what? Wait, negative 3, 1. Maybe I just forgot to do the correct answer. Yeah. Oh, there it is. I don't know where it was a second ago. Okay. So the answer is A. All right. This concludes today's review. Hold on.